Welcome to this tutorial on engine performance analysis. The engine used for this presentation is a 2-liter direct injection engine, and the engine is running at 2400 rpm. Also, it generates 125 newton meters of torque. So as you can see here, the engine rpm is 2400 and the torque value is 125 newton meter. The volumetric efficiency of the engine is 0.90, that is 90%. Two important metrics that is very critical, the brake power and also the mass flow rate, is going to be demonstrated in this video. The identification parameters are brake power and mass flow rate. So the focus now shift towards Matlab function block on the right side. You can see there is a Matlab function block which is selected and placed on the Simulink canvas. If you double click that function block here, you can see there is a function written inside. So inside the function block there is a function, and the function block accepts inputs. So let us consider this function block as the engine, and the engine is accepting inputs, and two important parameters have to be identified, that is the brake power in kilowatt and mass airflow rate in kilogram per second. So to identify this mass airflow rate, we have to substitute this rho value here. So that is the reason on the right side you can see to the Matlab function block, this inlet air intensity in kilogram per meter cube is identified before identifying the mass airflow rate. Let me explain you the function. So whatever is inside this function block, if I click this function block and show you whatever is inside here, the function name, BP, rho, MA, the same thing is again showed here on the left side. This is just for understanding. So our model is here. The function written inside the block is shown here. So the function name here is engine power and mass flow rate. This name represents the calculation of engine power, brake power and mass flow rate calculation. This function accepts the inputs torque, RPM, volumetric efficiency, pressure and temperature. If you go to the right side, engine accepts torque, engine speed, volumetric efficiency, inlet air pressure and inlet temperature. So these are the inputs for this function. Now with that function, it calculates the brake power and the mass airflow rate. In between it will find out the density of the air intake. So these are all the outputs. You can see these outputs on the right side here: brake power, inlet air density, that is in kilogram per meter cube, and mass airflow rate, that is in kilogram per second. So we have defined a function here. On the next step, we define the constants, the specific gas constant in joule per kilogram Kelvin, that is 287. And we were given the engine is a 2-liter engine. So the engine volume L is taken as 2 liters. The calculation is done for the pressure. The pressure is converted into Pascal, followed by the temperature conversion in Kelvin. Then in these two steps, the brake power is calculated and converted into kilowatt. The brake power calculation, 2 into pi into torque into RPM by 60 is the formula for brake power calculation. We get the brake power in watts. To convert it into kilowatt, we have to divide it by 1000. So that happens in the next step. Now we have to find out the mass flow rate. The mass flow rate is nothing but the 0.5 into volumetric efficiency into the inlet air density rho into engine volume by 1000 into RPM by 60. So here this rho must be calculated because it is unknown here. So for calculating the rho, we have this equation: pressure by R, the constant R, gas constant R into temperature K. So this is the way the steps are calculated. Now let us go and try to substitute the inputs to the function block. So let's go to the question now. So the torque is given as 125 Newton meter. So let me give torque as 125 and the speed is 2400 rpm. Okay, then the volumetric efficiency is 90%. So 0.90 is the volumetric efficiency. The inlet air pressure is given as 75 and the temperature is given as 40 degrees. So inlet air pressure is 75. The temperature is 40 degree. Okay, so now we have given the inputs. So this inputs go into this function, where this function is inside a Matlab function block in Simulink. So you can see the same function is written. This function is taking torque, RPM, volumetric efficiency, pressure and temperature, which we have already given. Now it will give us the brake power, the rho, that is the density of the air, and the mass airflow rate. So let me try to run this. As of now, you can see on the right side, all these brake power, density of air and the mass airflow is reading 0. Now let us try to run the code. Immediately the function takes up this input arguments and it is giving out required output parameters. That is the brake power. We are getting brake power as 31.42 kilowatt. Inlet air density is 0.8345 kilogram per meter cube. Mass airflow rate is 0.0375 kilogram per second. So I repeat the steps once again. The function is declared and the input arguments are given in. Then it begins to take up the input arguments and it converts it into the outputs, that is brake power, air density and mass airflow rate. Following the air density calculation, the mass flow rate is calculated, which is really essential for evaluating the engine's combustion efficiency. Then the Matlab function precisely here enables the measurement of how to design the operational parameters influence engine performance. So the analysis thus concludes with a clear understanding of the engine dynamics, highlighting the power of Matlab, that too the power of Matlab function block in this calculation. Thank you for attending this presentation. For further exploration on the same topic, the same domain, please watch our other videos. Thank you so much.